Hey guys, welcome to another video for pre-calculus. In this video I'm going to be doing two word problems from 5.2, and we're going to still be verifying trigonometric functions, and we just want to apply what we've been learning to some actual real-life problems. So the first problem here is fireworks. Let's read along with me here. So if a rocket is launched from ground level, the maximum height that it reaches is given by h equals v squared sine squared theta divided by 2g, where theta is the angle between the ground and the initial path of the rocket, v is the rocket's initial speed, and g is the acceleration due to gravity, 9.8 meters per second squared. Alright, so part A is asking us to verify, and I'm going to go ahead and start writing here. Verify v squared sine squared theta divided by 2g, and this is the initial equation that was given to us, so this most likely is the actual simplified version. And then we have, it's asking us to verify that it equals v squared tangent squared theta over 2g secant squared theta. And yeah, clearly the right side is a more complex version of what's on the left. So that's where I want to put my attention. And quickly my eyes are drawn to tangent squared theta and secant squared theta. Now you'll notice here that v squared is the same on both, and also 2g is the same. So that means I'm essentially verifying that sine squared theta will equal tangent squared theta divided by secant squared theta. All right, well, let's get started. Let's see here. Where do we want to start first? Well, why don't we look at tangent theta, tangent squared theta. Tangent squared theta, this is a quotient identity because I can change this to sine squared theta over cosine squared theta. And that is divided by secant squared theta. And secant squared theta is a reciprocal because I can change that to mean, or to say 1 over cosine squared theta, right? And so I have two terms that are divided by division. And what I would like to do is have my denominator, bring my denominator up to my numerator. And so to do that, I'm going to multiply by the reciprocal of 1 over cosine theta, which is cosine squared theta over 1. I'm just going to flip it. And so this is what that's going to look like. I'm going to end up with sine squared theta over cosine squared theta multiplied by, and again, the reciprocal of this, cosine squared theta over 1. And right off the bat, I can tell here that I can cancel these out, and I'm left with sine squared theta over 1, which is just sine squared theta. And that is, in fact, what my goal was right here. I have just verified part A. So now I can bring back my what was in blue, which is my v squared over 2g. So so I know that sine squared theta was multiplied by v squared over 2g. So that was my original equation, right? So now let's take a look at part B. It says, suppose that a second rocket is fired at an angle of 80 theta. So theta is 80 degrees. And the initial speed is 110, so that's velocity, 110 meters per second. And then and I want to find the maximum height. What is h? And then of course I know g also, that is a constant, 98 meters per second squared. So now this is a matter of just plugging in my known values to find my h. So v squared again is 110 squared meters per second times sine squared 80 degrees divided by 2 times 9.8 meters per second squared. So I plug that into my calculator, and I'm going to get an approximate answer of about 598.7 meters. And this is my approximate height. So at 80 degrees from the ground, and with the initial speed of 110 meters per second, my rocket will go a maximum height of roughly 598, 600 meters. Okay, well, let's take a look at number 33 now. All right, so number 33, it's a photography question. So the amount of light passing through a polarization filter can be modeled as I equals I sub m cosine squared theta, where I is the amount of light passing through the filter, and then I sub m is the amount of light shined on the filter. And theta is the angle of rotation between the light source and the filter. So I want to verify, and you notice that my given equation in the paragraph is mentioned first. So I sub m cosine squared theta. So that's my simplified version, and this is what I want to verify, that this equals what's on the left. And you can tell this is my more complicated version of this equation. So that means my attention is going to be drawn here. So let's see. My attention goes to this immediately, cotangent squared theta plus 1, because this is a Pythagorean identity, and this equals, let me simplify, I sub m minus I sub m over cosecant squared theta. All right, so I've simplified that just a bit. Now the next thing I notice is that I have two of the same terms, I sub m. So then I can factor that out. I can factor out as I sub m 1 minus 1 over cosecant squared theta, close parentheses. So you'll notice that everywhere I have a 1 here, that is where I used to have an I sub m. I've just extracted that term out. And let's see, what can I do next? I notice here, this is a reciprocal property here, cosecant, because 1 over cosecant theta equals sine theta. So then that means everything in here I can replace with sine theta. And because I have an exponent of 2, I can just say it's sine squared theta. So then my new problem is I sub m times 1 minus sine squared theta. Okay, so I'm getting closer to simplifying this. And 1 minus sine squared theta, again, I'm staying in the Pythagorean theorem, or Pythagorean identities, because that equals this, everything in green here equals cosine squared theta. So then my final equation is I sub m times cosine squared theta. And if I go back to my problem, I notice here that that's exactly what it is simplifying to. So that's that. I've successfully verified number 33. Well, I hope these problems helped. And when you're verifying these equations in real life situations, all you're basically doing is making the equation easier to work with, making it more practical. And it causes you to have less steps to do. Just like if you go back to number 19, because once you've simplified the problem, then it's just a matter of filling in the gaps, filling in the variables, the values of the variables, plugging them in, and then chugging out an answer, and then moving forward with your experiment. So in any case, hope this helped, and good luck in your study.